Section 5.3, Sum and Difference Identity. Difference identity for cosine is cosine A minus B equal to cosine A minus cosine B. Can we just distribute the cosine, make it like equal? Is this the identity? Let's try to plug in some number. For example, if A equal to pi over 2 and B equal to 0, then first we're gonna plug into the left hand side here. Okay, A minus B, which is gonna be pi over 2 minus 0. And that will be equal to cosine pi over 2. Cosine pi over 2, that will be equal to 0. Now, we're gonna do the same thing on the right hand side. We're gonna plug in A equal to pi over 2 and B equal to 0 on the right hand side. Okay, cosine pi over 2, that's equal to 0. Minus cosine 0, that's gonna be equal to 1. So on the right hand side, this is gonna be equal to negative 1. So we're gonna say this is not an identity. They are not equal to each other. Okay, so what is a cosine A minus B equal to? We will prove the difference identity for the cosine. And this is gonna be the formula that we need to use it in the future. Difference identity for cosine. We will prove the difference identity for cosine. So I want you guys to highlight this one. Now we are going to prove it using the unit circle. Okay, we do have the figure A here. We have an angle A and angle B. Let me explain this picture. Okay, this is the unit circle. Okay, unit circle, the equation will be x squared plus y squared equal to 1. Talking about the radius here, that will be equal to 1 here. Okay, and then I do have the straight line and I create the angle. That will be the angle A. So I do have a coordinate here. Remember the unit circle, we're gonna say x equal to cosine A, y equal to sine A. Okay, that will be the point here. Cosine A and sine A. Okay, right? If you guys don't remember this part, you could review the lecture of session 3.3. We talk about this, the unit circle. Okay? And then we do have another angle. Let's say from here. And then we call this is gonna be the angle B. So for this coordinate, that will be cosine B, sine B. Okay, same idea. Since this is a unit circle, the radius of this length is gonna be equal to 1. When we have these two angles, angle A and angle B, I want to find the distance between these two coordinates. The distance between these 2 points, I'm gonna call this is gonna be my D. Okay, right? Now, go back to my picture here. You're gonna see this picture. This is what I just did from here. And then, inside the triangle, that is an angle, and we call this is the B angle A minus angle B. Okay, right? The whole angle A, take out the angle B, will be equal to the angle in this triangle, A minus B. And then we're gonna shift this triangle into the figure B here. Okay, we kind of like shift it over. So this is 1. I'm gonna go back here. The angle A and B, I'm gonna put it on the x-axis. So we do have the same distance. And this angle, that will be angle A minus B, right? So the coordinate will be cosine A minus B and sine A minus B. And since this point will be on the x-axis, and I will know the radius that's equal to 1. So the coordinate of this point, that will be 1 and 0. Okay, right? You guys understand these two pictures. Now, I'll be using the distance formula to find the D. Okay, I do have the formula D equal to square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, Then I will be using these 2 points. Okay, plug into this distance formula. So I'm gonna get this. Cosine A minus cosine B squared plus sine A minus sine B squared. Okay, we're looking for the distance D here. And then for the figure B, we're gonna do the same thing. This time, we're gonna use this coordinate with 1 and 0. Plug into this formula. Since both of the distance equal to the D, so I'm gonna say these two will be equal to each other. Now, I'm gonna simplify it. First, I'm gonna take square for both sides to get out of the square root. Now, I'm gonna distribute it like 1 by 1. Okay, remember the formula A minus B squared? That's equal to A squared minus 2AB plus B squared. Okay, I'm gonna expand it for this guy and also this one. Okay, so on the left hand side, you're gonna see A squared cosine squared A minus 2 cosine A cosine B plus cosine squared B. And then the second one, same idea, sine squared A minus 2 sine A sine B plus sine squared B. Equal to, on your right hand side, same thing, cosine squared A minus B minus 2 times cosine A minus B plus 1. And this one, since this is going to be equal to 0, so I only left with the sine squared A minus B. Now, we're going to use the identity. Cosine squared A plus sine squared A, that's equal to 1. So first, cosine squared A plus sine squared A, that's equal to 1. I do have a 1 here. And then cosine squared B plus sine squared B, that's also equal to 1. On the right hand side, cosine squared A minus B plus sine squared A minus B, that's also equal to 1. So I will have this guy. Now, I want you guys try to simplify it. On the left hand side, I do have a 2, right? And then right hand side, I do have the 2 also. And then we're gonna subtract 2 for both sides. Okay, we could see we do have the negative 2 for all of them. So we're gonna divide it by negative 2 for both sides. You will have this one. So this is our identity, cosine A minus B. That will be equal to cosine A cosine B plus sine A sine B. I need you guys memorize this formula. When you see the form cosine A minus B, make sure you don't distribute the cosine for each of them. Okay, you have to apply the identity. And then keep in mind, when it's a cosine, A minus B, that will become positive here. Cosine cosine plus sine sine. Some identity for cosine. We just proved the cosine A minus B, right? Now, we want to prove the cosine A plus B. Okay? And we already proved the cosine A minus B. We could apply this formula. So what we're gonna do, cosine A plus B, we could rewrite it as A minus negative B. Okay? A minus negative B. And then we're gonna use this formula. Okay? We do have cosine A minus B from the previous identity. So we're gonna plug it in. And then remember cosine negative B, cosine is going to be on quadrant 4 is a positive. Negative B, talking about you going clockwise. Okay, so this guy will be positive again. But sine negative B, that will become negative sine B. So we do have another identity for cosine. When it's a cosine A plus B, same idea. We do have cosine, cosine, sine, sine. But when it's a positive, we'll make it like negative. So far, we do have the cosine of a sum of difference. I need you guys remember it. If I give you cosine A plus B, you should be able to break it down into here. Or if I give you guys the right hand side, you're going to recall that this is talking about the cosine of a sum of difference. Now, let's try to do the example. Find the exact value of the cosine 15 degree. When they say find the exact value, means I don't want you guys to use the calculator, okay? Your final answer should be stay with like the square root form. And then to find the cosine 15 degree, so I need you guys to remember the special triangle, the 60, 45, and 30, right? Without using the calculator, we could tell what is a cosine sine tangent with the 60, 45, and 30 degree. And now we do have the 15 degree. So you're gonna think about it, these three angles. How can we add or subtract to get the 15 degree? We could do 45 minus 30. Or you could do 60 minus 45. Okay, both of them, you're gonna get the same answer. But I would choose this one, cosine 45 degree minus 30 degree. Now you're gonna apply the cosine sum or difference identity. That would be cosine A, cosine B, plus sine A, sine B. Plug it in. And then you're gonna use the special triangle to figure out what is cosine 45. Cosine 45, that will be equal to 1 over rad 2. Means that will be rad 2 over 2, right? Rad 2 over 2 times cosine 30, which is going to be rad 3 over 2, sine 45, rad 2 over 2, and sine 30, that will be equal to 1/2. And then multiply it. You should get square root 6 over 4 plus square root 2 over 4. They do have the same denominator. So this is going to be your final answer. You can use your calculator to double check cosine 15 degree. Is it equal to this guy? Now find the exact value of cosine 5 pi over 12. When they given the degree, you're going to use the degree. But when they given the radians, you have to use the radians. So 5 pi over 12, you're going to use the pi over 3, which is going to be 60 degree. Pi over 4, which is going to be 45 degree. Pi over 6, that will be 30 degree. Okay, try to add or subtract to see if you could get the 5 pi over 12. Okay, so pi over 4 plus pi over 6, that will be equal to 5 pi over 12. And then we're going to apply the cosine formula. Cosine A, cosine B, minus sine A, sine B. And then use the special triangle, figure out. Simplify it, you're going to get this guy. Okay, C. Find the exact value of cosine 87 degree, cosine 93, minus sine 87, sine 93. Okay, think about it. I do have a cosine A, cosine B, minus sine A, sine B. Okay, what is going to be equal to? That will be equal to cosine A plus B, right? So I could write it down, cosine A plus B. So 87 degree plus 93 degree. Add it up, you're going to get cosine 180 degree. What's cosine 180? Think about the unit circle. 180 is going to be on the quadrant 2 like here, right? So cosine is going to be -1. Co-function identities. Cosine 90 degree minus theta equal to sine theta. And then sine 90 minus theta equal to cosine. Okay, this part we mentioned about it on the chapter 2. Let me see. Session 2.1. Okay, we covered this part already from the session 2.1. If you don't remember, you could review the video lecture from the session 2.1 here. And the same identity can be obtained for whole number domain by replacing 90 degree with pi over 2. You could use the degree or you could use the radian. Using cofunction identities to find the data for one value of theta or x that satisfies each of the following. So cotangent theta equal to tangent 25 degree. Okay, so think about it, cotangent and tangent. We could apply these cofunction identities. So I would change it like cotangent, I could revise it to tangent 90 degree minus theta. Since both of them has a tangent, we would just like cancel out, make it like 90 degree minus theta equal to 25 degree. And then theta equal to 65 degree. Hey, I need to remind you guys that for this example, we only need to find one value of theta, okay? It can be more than one answer because remember that the tangent and cotangent, the positive can be on quadrant 1 and quadrant 3. We are working on the quadrant 1, so theta is going to be 65 degree. If this is a quadrant 3, that will be 180 plus 65 degree. It can be more than one answer. Okay, B, sine cosine. So do the same thing. I could replace the sine theta equal to cosine 90 minus theta. Okay, so simplify it. Theta will be equal to 120. Okay, C. Again, find one value of theta that satisfies the following. That's a cosecant and secant. So we always replace the one with the variable. Okay, so we're going to replace the secant. That will be cosecant pi over 2 minus x. Okay, we have to use the radian because the given is the radian. Okay, simplify it. So x equal to negative pi over 4. Note, because trigonometric functions are periodic, the solutions in example 2 are not unique. Okay, we talked about it already. It can be more than one answer. Okay, we only give one answer for this example. Applying the sum and difference identity. If either angle A or B in the identities for cosine A plus B and cosine A minus B is a quadrantal angle, then the identity allows us to write the expressions in terms of the single function of A and B. Let's try on example 3. Write cosine 180 degree minus theta has a trigonometric function of theta alone. So we're gonna apply the identity, right? Cosine A, cosine B plus sine A, sine B. And then we know cosine 180 is going to be negative 1. Sine 180, that will be 0. Okay? So that's going to be equal to negative cosine theta. Okay, example 4. Suppose that sine S equal to 3 over 5. Cosine T equal to negative 12 over 13. And both S and T are in quadrant 2. Find cosine S plus T. So we do have a two method for this kind of the questions. Method 1, we're gonna sketch an angle in the quadrant 2. Okay, because they mentioned it's gonna be on quadrant 2. Such that sine S equal to 3 over 5. So we could have this picture. Okay, sine S, talking about this angle, sine will be opposite over hypotenuse. So that's a 3 and 5 here. Now we want to find out what is your x. Okay, remember the Pythagorean theorem. Plug it in. You should get x equal to plus minus 4. Okay, since x is on quadrant 2, so x should be negative. And then we could find it out. What is cosine s? Cosine s will be adjacent over hypotenuse. So negative 4 over 5. And then we're gonna do the same thing for cosine t equal to negative 12 over 13. Still, we are in the quadrant 2. And this time, we have to figure out what is my y here. So I want you guys try, plug it in, find me what is your y equal to. Okay, plug it in. You should get y equal to plus minus 5, right? But since y is in quadrant 2, so above the x-axis, so y should be positive. And what is sine t equal to? Sine t will be equal to opposite, which is going to be 5 over 13. Now, we want to find out cosine s plus t. So we're going to apply the formula here. Cosine A, cosine B minus sine A, sine B. And we already know cosine S, cosine T, sine S, sine T, right? Plug it in. Five times 13, that will be 65. You should get 33 over 65. Okay. Method 2, okay, we just use the method 1 to find out the example 4. Now we're gonna redo it one more time using the method 2. We're gonna use the Pythagorean identities here to find cosine s. We call that sine squared s plus cosine squared s equal to 1. And s is in the quadrant 2. Okay, we know the sine s already. So we could plug into this identity. Subtract 9 over 25 from 1. You should get 16 over 25. Take the square root. And one more time is a quadrant 2. Cosine s supposed to be negative. Okay, so you get cosine s equal to negative 4 over 5. Same idea for the cosine t equal to negative 12 over 13. We could plug into the same identity. Okay, I want you guys try. Okay, use the same identity, plug it in, cosine t equal to negative 12 over 13. Figure out what is the sine t equal to. Okay, make sure you determine the sign. It's going to be positive or negative. Okay, check your work. You should get sine squared t equal to 25 over 169. Take the square root, and since sine is going to be in the quadrant 2, that's a positive. So you could get sine t equal to 5 over 13. So now you could use the same formula. Okay, plug it in just like the method 1. Okay, both of the methods are good for the exam and the homework. Okay, depends on which one you think is easier. Example 5, verifying an identity. Verify the following equation is an identity. So we need to prove it. We always want to work with the complicated sign. So we start with the left hand side here. Okay, and then secant, that will be equal to 1 over cosine. Okay, 3 pi over 2 minus x. So we could apply cosine A, cosine B plus sine A, sine B. What is a cosine 3 pi over 2? That will be equal to 0, right? This one will be negative 1. So we should have this one here. Simplify it. 1 over sine, that will be equal to cosecant. Okay, that will be equal to your right hand side. So the given equation is an identity. That's it.